Hi guys. Okay, we're back today. Trying to continue off from where yesterday was. So what I want to do today is to kind of take up part of the exploration so that we can see what the exploration was trying to get you to realize about remainders. If you worked on it, I'm sure you came up with a conclusion about what was going on. I want to take up just two little parts and then I'll get on to the next lesson. So from the exploration, basically, it was split into parts. There was a procedure part, there was an analysis part, and then there was kind of a conclusion part where you had to come up with some things. So from the procedure part, I'm just pulling number 3 off. Basically what they said in the procedure part, you gotta move, Morgan, I can't see, okay, is that if you have some function p of x, and this one happens to be a cubic function, if you try to substitute in a specific value into that function, you can come up with a result. So the first one, they say, take this function p of x, which is cubic, and substitute in the number 4 for x. So when you substitute in the number 4 and you do the arithmetic, you find that p of 4 is negative 121. Great. What does that tell us? We don't know. Okay? So then it says, I want to do more about this 4. I want to check to see if x minus 4 is a divisor. So remember when we did long division and then we did synthetic division? They want you to see, is x minus 4 a divisor? So when we talk about x minus 4 being a divisor, that means we're actually substituting in the number 4. Because you're saying if it's a factor, then x minus 4 has to equal 0. If x minus 4 equals 0, what does x equal? 4. Now we've called it k to make it simpler. We put that on the outside of our little bracket here that we've made for synthetic division. Then each of these numbers, remember, comes from the coefficients in front of each of the values, starting with the highest degree and descending. Make sure you don't miss one. So if it goes cubed, the next one must be squared, the next one must be to the power of 1, and then the constant. So I've set up here the 4, which we're putting in for our k value to check if x minus 4 is in fact a divisor, and then putting in the coefficients, negative 2, 3, negative 9, negative 5. Now remember when we do synthetic division, the first step is to drop the negative 2 down. After you've dropped the negative 2 down, you then multiply. Negative 2 times 4 is negative 8. Then you add the column to get negative 5. Negative 5 times 4 is negative 20. You add the column to get negative 29. Negative 29 times 4 is? Negative? Negative 116. When I add those, I get negative 121. The same number I got when I substituted 4 in. Okay, you get the exact same value. So what this tells is this is not an exact divisor because there's a remainder, but the remainder happens to be the exact value that you got when you substituted this in. So that gets to thinking, well, what kind of remainder would be optimal to tell you if it's a true factor? What type of remainder is optimal? Right now, it says this is a factor if I have this remainder of negative 121. So what factor is optimal? The factor that's optimal is 0. If we can get it to have a remainder of 0, then we know it's a true factor. It's a true 0, in fact. So you go into the analysis section, I picked up number 2. It's a simple quadratic that we would already know how to factor if we wanted to. But let's just check. Okay? We want to do a test point. And the test point we want to substitute in is a value that will give us an answer of 0. Because based on what we saw up here in the procedure, an answer of 0 would be equivalent to a remainder of 0, and that's what we're looking for. So when I sub in a negative 2 squared minus 7 times negative 2 minus 18, probably downstairs, wherever you were watching it. No, you weren't. Okay, go look for it. I'm working more. Okay, so then when you sub in the negative 2, you get an answer of 0. Let's just check with our synthetic division to make sure that's right. We put in a value of negative 2. Negative 2 is actually telling us if x plus 2 is a factor. Notice here we were checking is x minus 4 a factor, we subbed in positive 4. If we're checking if x plus 2 is a factor, we sub in negative 2. When we sub negative 2 in, we again take the coefficients. Front of x squared a 1, a front of x a negative 7, the constant a negative 18. We drop them down, we multiply, we add, we multiply, we add, we get a remainder of 0. Remember what's left here. We know x plus 2 is a factor, and what's left here is just 2 terms, so it's linear. X minus 9. If we had have tried to factor this originally, we would have got those same results, and this leaves us with a remainder of 0. These are true factors. They are true zeros of this quadratic function. Okay, so by you doing that exploration last night, you should have been able to get the idea that if we can find a value to substitute into x here that comes out with an answer of 0, we know that's one of the factors. And if we know one of the factors, through a little synthetic division, we can find more factors. Okay, so that's going to be the goal moving forward in today's lesson. So I'm going to erase this, then I'm going to put up a couple examples for today, and then you should be good to go to move on to the next homework. Okay, then we'll only have one lesson left in chapter 3.
Mommy?
Yes, baby?
Can I, at the end of this, are you almost done?
I'm almost done, yes.
Can I show everything?
Okay, so we get that all erased. You want to show them right now?
Yeah.
Okay, show them.
But Mommy, I want to show them the things in it.
Okay, well, just wait. Okay, so the basic idea that we want to have here is if we have some function p of x, okay, this is going to be the biggest issue we have.
Just need to do something.
If we can find a value for x, a k value, in which p of k equals 0, then we know that x minus k is a factor. Okay, so we have some function p of x. Okay, come show us Morgan quickly. Morgan made this night light. She put a light inside. She painted her jar. Well, that was her art project. Okay, good. Move.
For my birthday.
For your birthday, you're right. Okay, so if you have some function p of x and you substitute a k value in and you can get a result of 0, okay, your output is 0 for whatever k value you put in, that means that x minus k is a factor. Okay? One issue that you want to be sure of is that if you have, k might not be an integer, it might be a rational number. So we'll get to that when we see that type of example. But this is the main idea. If you look at the note for today, which looks like this, you'll see it written in much better math jargon. I don't need to rewrite exactly what you have on the note in front of you. So that's going to be the issue that we have. So what we want to do is basically set up a way for us to solve these. So if I just kind of leave this as what we're looking for, on the back there's an example, and this is a fairly in-depth example. There's only 3 examples on here, and the first one's is a bit of a doozy. So what it's saying is factor 2x to the 4, so we're looking at a quartic function here, minus 3x cubed minus x squared plus 18x, make sure I get this all right or it's going to be a disaster, plus 8. Okay? And the question is, how can we factor this? Well, we have to first find a factor. Okay? And finding a factor, oftentimes the factor divides into the last constant term. That's sort of a little trick you can use. So to pick a number like 7 is not going to work. To pick a number like 5 is not going to work. So oftentimes people will start, they'll try 0. If I put a 0 in for all of these, I'm left with an 8. That doesn't work. If I put a 1 in, you kind of just can do it in your head a little bit. If I put a 1 in, I'm left with a 2 here, minus 3. If I'm at negative 1, I'm at negative 1 more, negative 2, plus 18, plus 8. No, I'm not going to get it. So you have to do a little bit of trial and error, but usually it's divisible into this last thing. So I am going to attempt, I'm basically going to say p of x is this function, 2x to the 4 minus 3x cubed and because I just did some quick calculations in my head, I think 2 or negative 2 will work. We'll take a little look. If I substitute 2 in, you have to put it in everywhere an x exists. Make sure you follow your exponent laws in terms of the negatives. Put it in brackets when you substitute it in. You'll be able to get a decent answer here. So 2 times 16, 32. 8 times 3, 24. Minus 4 plus 36 plus 8. 36, 44, 40. 6. Oh, what did I do here? Oh, this was supposed to be 9, that's why. Sorry, 9, 72, 3. So 30, 68, 76, 72 minus 72 is 0. Okay, good. See, I maybe even make mistakes on this. Okay, so when we sub in 2, we get an answer of 0. So we now know that x minus 2 is a factor. We know that it is a factor. Okay, so we can put in to our synthetic division and try to find more factors. We know this will produce a remainder of 0, so that's why we want to put it in. So you go across like this, you put your 2 in because you know that will work. You list all in order. Remember, you're going from descending degree. Values in front here. And then you follow the rules of synthetic division like we did before. This has to drop down. You get a 2, you multiply, and then you add the column. And the big thing is this must be a remainder of 0. If that is not a remainder of 0, then you've made a mistake. And what this tells us is we now know the following. X minus 2 here. Okay, Morgan, move on the way. And then these, remember, this is a constant. This one's going to be degree 1. This one's going to be degree 2. This one's going to be degree 3. So this is 2x cubed minus 5x squared minus 11x minus 4. That is going to equal what we've called p of x for now. Okay, so we've started, we're going to back up. We've started to factor it. We got it from a quartic. We got one of the factors out that's linear, and now we're left with a cubic. We have to keep going. So let me erase the top part. I'll leave this bottom part here so we can still see it. Okay, so what we have right now is one of the factors and then a cubic function. We're going to call this cubic function q of x because guess what? Now we want to factor q of x. So we now have a new function which we've called q of x, and q of x equals 2x cubed minus 5x squared minus 11x minus 4. Okay, and with this function, we also want to find a factor. Okay, so again, you can look at the -4 and say it's essentially going to be something that's associated with -4, something that divides into it. So we're looking at 2, -2, 1, 4, -1, -4, really as our options of what could be the factor. So if you do a quick calculation in your head, try a 1. That's not going to work. I think -1 we might have better luck with. This is sort of trial and error at this point. You're just going to have to take the time to do it and figure out what works. So if I put a -1 in, let's see what we get. I get -2 minus 5 plus 11 minus 4, and I get 0. Exactly what I wanted. I now know, be careful of this, that x plus 1 is a factor. Okay, so we know x minus 2 is a factor. We know x plus 1 is a factor. And now we're going to be able to get it down to a quadratic. And what you already know how to factor from yesterday? Quadratics. So you put it in there exactly how you should. This becomes a -1. Put the coefficients, -5, -11, -4. Drop it down, becomes a 2, multiply, and simply add the columns. And what do you know? Remainder 0. We're very happy. We now have, from before, x minus 2. Our new factor, x plus 1. And then remember how you list these. This is a constant. This is degree 1. This is degree 2. So we have 2x squared minus 7x minus 4 equals what our original thing was, p of x. Okay? And the very last step that you have is, can you actually factor this?
Yep.
Okay? That is something from grade 10 that we worked on. That is something from grade 11 that we worked on. So we leave our two factors here. This happens to be a complex trinomial, but not a very difficult one. We know it has x's associated with it.
You done? I'm hungry.
Okay, soon, Morgan. So you just have to find two values that multiply to -4 that when you put it in here, it actually works. So +1, -4, do a little check. 1x, -8x is -7. So we now have all of the factors of this quartic function. By having all of the factors of a quartic function, we now know all of the zeros. You can find the end behavior, you can find the turning points. Okay? Yeah, you can sit on my lap. Okay, we have 2 more little examples that I want to get through. We're gonna go to erase first. Can you help me? Here you go. Stop talking like a baby.
And I have the other one. The other one's easier for me.
Nice. Okay, sit over here, Mommy. Okay, so if I do the last 2 examples, we'll get a better gist of it, and then you guys can start. So determine, is 2x minus 5 a factor
This is my brother's.
of 2x cubed minus 5x squared minus 2x, okay, Morgan, stop, plus 5. Okay, so the big key here and the issue that we have here is you're trying to find, is this one a factor?
Yes. It is a factor.
Well, remember what we have to do is we have to substitute in basically the 0 into this equation and see if you get a remainder of 0. See if your answer is 0. Well, the idea here is if this is a true factor, that means 2x minus 5 would have to equal 0. If you brought it over and solved it, it would mean that x would have to be 5 over 2. So this is really your test point. That's what you're substituting in. So if you call this equation p of x, or it's 2x cubed minus 5x squared minus 2x plus 5, you're simply substituting in this 5 over 2. If when you substitute in the 5 over 2, you get an answer of 0, then it worked. Morgan, just wait a second, please. Back up, please. Sit down. 5 over 2, 5 over 2, 5 over 2. So when you actually go about solving that, you will get an answer of 0.
Sorry.
Therefore, it is a factor. Okay, so just be aware, I just wanted to put this one in to make sure that you understood that they're not always integers. And if you have a value like this, it's the same idea. You check to make sure. Obviously, you can do this arithmetic yourself to find out that it's an answer of 0 and that it works. Okay, the very last question involves an unknown somewhere else.
I watched the first video.
Just wait.
What?
We're almost done. Example 3 looks like this. Find k, whatever k is, if x minus 3 is a factor of, Morgan, just don't block the board,
I'm going to wait till hell.
of f of x equals 2x cubed minus x squared plus kx plus 36. That's what we are looking for. Find k if it is in fact a factor. If it is a factor, what do we know the answer is when you sub it in? If it is a factor, I know f of 3 must equal 0. That's the whole idea of this whole thing, is you're looking for remainder 0. You're looking for a value that is 0. So I know if I substitute a 3 in for x, I should get an answer of 0. So that's what I'm going to do. I'm going to put a 0 on this side, and everywhere I see an x here, I'm going to substitute a 3 in. Okay, when you do that, you're able to solve this as now just an equation that's going to turn into a linear grade 9 type equation that you can solve. So leave the 2 here. 3 cubed is 27. 3 squared is 9. 3k, we can change that to 36. 54 minus 9 plus 3k plus 36, 54, 45, 70, 81. Is that what I have? I think that's what the answer was. Morgan, where's my answer sheet? I'm going to put my question sheet. I don't have a calculator. Oh yes, 81. Good. Okay, so then to solve, bring the 81 to the other side. Divide both sides by 3.
Can you take your elastic?
And you get that k equals negative 27.
Your elastic.
Okay, a little bit of a longer lesson today, over 20 minutes. But the idea is you're going to get a lot of practice with synthetic division. You're going to get a lot of practice with finding factors and understanding the idea of a remainder of 0. Morgan wants to show you the braid she did. She's learning how to braid hair. Very nice, Morgan. And if you look on D2L, the homework is listed right under this lesson. This is a bit of a monster homework. So I would say I'm going to put this lesson up today, and this is Tuesday. I probably won't put another lesson up till Thursday because I want to make sure you can get through those. Again, if you have questions, please email me. I will try my best to answer. We're home anyway. The best I can to either write down a solution or to post some solutions online for you guys. Okay, hopefully you're making the best of this. Stay home, please. Stay safe. And hopefully we'll be back at school before the end of the year. Right, Morgan? You want to go back to school?
No.
No? You like staying at home with
I
Mommy?
took her hair out.
Oh, you took her hair out. Okay. See you guys soon.